reflector was placed there is sufficient enough evidence to falsify this claim. Of course, as stated above, we've not measured the one-way speed of light, so they couldn't know the distance. Several physicists have pointed out that while relativity assumes the vacuum speed of light is the universal constant, it also shows that the speed can never be measured. Specifically, relativity forbids you from measuring the time it takes light to travel from point A to point B. We can thank Run Zhu Kao for his paper in 2015 reconsidering relativity. What if we look at the so-called photo and video evidence of the moon landing? We see issues right off the bat. The lack of the blast crater from the lander itself. If the lunar module indeed landed on the moon's surface with the force required to breach its gravitational pull, why is there no discernible evidence of such impact? How about the lack of stars absent in the background from videos and photographs? Yet there are also inconsistencies in the testimony of multiple astronauts. Some say, yes, we can see stars while we're up there on the moon, out in outer space, while others say that we cannot. Despite the absence of the supposed atmospheric interference on the moon, excuse me. Despite the absence of atmospheric interference on the moon, this inconsistency raises questions about the accuracy of their observations and the credibility of their testimonies. Now, if the stars were indeed visible in the vacuum of space, as they're claimed to be, as they should be, why did some astronauts claim otherwise? So for my opponent tonight, which astronaut will you be willing to call a liar and why? How about the lack of matching footprints on the surface? That when the supposed astronauts' boots that walked on the moon, their footprint did not match that which was in the museum. We can also confront the issue of radiation exposure beyond Earth's protective atmosphere. Studies of the Van Allen radiation belt suggest that passage through these intense radiation zones would have posed insurmountable risks to the health and safety of the astronauts. How then do we reconcile the apparent absence of radiation sickness or long-term health effects among the Apollo astronauts? Without any protection, astronauts are more likely to have both acute and chronic health problems, such as cataracts and heart diseases. Additionally, they may suffer from short-term radiation illness and risks of cancer developed in long term. This is, of course, based on a person's age, gender, and this is from Smithsonian Magazine. Well, we should be able to analyze the data from the telemetry to understand how it was done in 1969. Oh, shit. They lost it. Damn it. Well, perhaps we can examine the original moon landing footage. There must be reels and film that we could examine that would put this debate to bed, right? Oh, nope. Sorry. They recorded over that too. Lost it. Maybe on the next one. Furthermore, the technological limitations of the 1960s raised legitimate concerns about the feasibility of safely transporting humans to the moon and back with computing power less than that of a modern-day smartphone. But I'll do you one better. The computer on the lunar lander had a 2,048 word of erasable magnetic core memory and 36,864 words of read-only core rope memory. So let's do some conversions. If we took 3,072 bytes of RAM to 8 kilobytes of RAM, we first have to understand the conversion. So 1 kilobyte is 1,024 bytes. So 8 kilobytes of RAM is 8 times 1,024 bytes, which is 8,192 bytes. Now, if we compare that, 372 bytes is less than 8,192 bytes, almost 2 times less. So why did I convert it to 8 kilobytes of RAM? Well, 8 kilobytes of built-in working RAM up to 16 8 kilobyte switchable working RAM pages for a maximum of 128 kilobytes of external RAM is what was available to the Nintendo Game Boy in 1989, 20 years later. So what you have to tell me then is that the lunar lander had less than half of the RAM capabilities of the gray brick in 1989, but we can't figure out how to do it today. Last but not least, of course, we had the moon rocks. They brought back the moon rocks.
1 minute
They're
left.
like, it's the 1 minute. Gotcha. They brought back the moon rocks, so we must have gone. Actually, not the moon rocks. They were presented to the Prime Minister of the Netherlands. Turned out to be petrified wood. There's articles on that. In conclusion, as we embark on this debate, let us keep an open mind and approach the evidence with a spirit of skepticism tempered by reason and avoid ad hominems and logical fallacies. Our quest for the truth demands nothing less, and my favorite part of this debate with my interlocutor is that he cannot deny any of the videos in which I'm going to show tonight. So thank you so much.
All right. Well, thank you as well, Big Country, for being here. Welcome to Modern Day Debate. We welcome new speakers here and also welcome you in the live chat. Thank you for being here and joining us for our discussion. Just want to welcome you all here. We're a neutral platform hosting debates on science, politics, religion. We hope that you like it enough to hit the like button and share it out in those spaces you like having these discussions. We do have a live event that's coming up. We're going to talk about that after TJump's opening statement. So, TJump, you have 10 minutes on the floor.
All right, so I listened to some of what the opponent said. The first thing he said is, "We've reflected lasers off of." Oh, no, it was the second thing. We've reflected lasers off the moon, therefore the reflectors are fake. I don't know how little research he's done on this, but yeah, we can reflect lasers off the moon. That's pretty easy. It's a big rock. The problem is the reflectors bounce the lasers back in the direction they are sent from. So any direction you shoot a laser at the reflector, it will then take that laser and bounce it directly back in the direction you reflected it from. Reflecting laser off the moon doesn't do that. It doesn't work that. It's a big ball. It's made of rock. It doesn't reflect things back directly in the direction that you shoot something at it. Not how it works, but it does for these reflectors. And the only things that do this are man-made. Congratulations. There isn't some special nature mirror that automatically reflects things back in the way they came. Only man-made objects do this. So there necessarily are man-made objects on the moon. Problem solved. He said, for longer distance, you need more fuel. That is wrong. That is literally not the case. The objects that have the greatest distance have no fuel left. They don't have any fuel. They're just floating because objects in motion remain in motion. Newton's very first law. Thank you, Newton, debunking firsts from thousands of years ago. Amazing. So no, you don't actually need more fuel to travel longer distances. You need more fuel to change directions at longer distances. So that one was debunked. What else? I don't remember the other thing you said. Yes, there are some moon rocks that have been proved to be petrified wood. Is this evidence that all of them are? No. It's a very stupid argument. How can we tell the difference between petrified wood and a moon rock? There are, I forget what they're called. There's a big word for it, but it's hydrogen compounds or hydrogen and oxygen compounds are found in earth rocks, all of them. They are not found in moon rocks, any of them, because there wasn't any at their formation. There, therefore you know which ones are moon rocks and which ones are real rocks, human earth rocks, because all earth rocks have this water stuff, water-based compounds in it, and moon rocks don't. So we can tell which ones are which. Problem solved. All of the garbage he said about the moon landing has been debunked a billion times. There's literally just no point in going over. Just watch, what was it? The show with Adam or whatever, where they did this. It's Adam Conover. He debunked this, and then the guy with the weird hat and the orange haired guy, the comedians who did MythBusters. They debunked it. So all of those FERF ideas have been debunked, and they should just die, just move on, get a new hobby. Let's see what else. We can bounce ham radio waves off of the moon. Like you can send radio waves travel at the speed of light. They can hit the moon, and they'll come back, and you can receive them. So we know how far away the moon is, how big the moon is, where the moon is, and there's nothing around the moon. Like, because if there was something else there, the other things would also bounce the radio waves back, because radio waves are just massive things that just go in all the directions. And so if it hit anything else other than the moon in the general vicinity, like a big dome of some kind, a flurf dome, we're going to call it the flurf dome, it would bounce the radio waves back and would receive a signal. If the radio waves went through it and hit something behind it, like if there was nothing there, and then only came back from that one point, we know it's an object. That's how radar works. It's just radar. And we know it's radar because it's the exact same radar we use with submarines. That's what radio waves are. Radar, are radio. So we can tell for sure that the moon is there, the correct distance it is. It's solid. It's a rock. We have samples of the rocks. We can prove that those samples do come from the moon because they don't have any of the hydrocarbons that are in Earth rocks, because there wasn't any at the formation of the moon. Congratulations. We can prove there are man-made objects on the moon because the reflectors reflect things back directly in any direction that you point the laser at it, which the moon did not do before. I don't remember the rest of the junk. You don't need more fuel to go more distance. That's just simply false. Like no, objects in motion remain in motion. And I'll conclude there.
All right, thank you, and everybody. We are going to kick it into open discussion. And I do want to remind everybody, we do Q&A at the end. So if you put in a super chat, we'll make sure to read those questions to our speakers. If you're listening in on podcasts, where all of our debates get uploaded within 24 hours, and you want to ask a question to one of our speakers, make sure you are hanging out and you like and subscribe to the Modern Day Debate YouTube channel. Also want to let you guys know about some exciting upcoming news, which is going to be a live event in Texas. this. So James is going to be helping out with Minds Fest, and the links are going to be in the description. So you can see that next to me here, and I can pin that in the chat as well. So let's go into an open discussion, and thank you everybody for being here.
Cool. Sorry, I was on mute there. So let me just clarify real quick to jump. What I said was that as early as 1962, we were able to reflect lasers off the moon prior to any retroreflector claimed of being put there. I didn't say that we bounce things off of retroreflectors, therefore they don't exist.
What does that have to do with what I said?
You said that I had said that we could bounce lasers off retroreflectors, therefore they're not real.
And well, you did not say that. What was what you were really saying? What was the argument you were making there?
No. So what I said was as early as 1962, we were able to bounce lasers off the moon prior to any retroreflectors being said to have been put there.
Therefore, what was the implication of that?
Therefore, it is not evidence to suggest that indeed we have retroreflectors on the moon.
Right. And so how I responded was I said, retroreflectors are objects that when you bounce a laser on it, it comes directly back in whatever direction you sent the laser from. So like if you sent the laser from the right, the laser will then go inside the retroreflector, bounce around and go directly back towards wherever you sent it from. That didn't happen in any of the examples you listed before.
Mhm.
That's the difference.
I got you. So the retroreflector, you're saying that we shoot a laser at a supposed retroreflector and then the laser comes right back?
Directly back, yes. That's what for the retroreflectors, what they do is any direction that you hit it from a laser, it will cause it to bounce directly back in the direction that it came from.
So a laser comes back, not data on a computer.
Yes.
So I'm sorry. So yes, it's a laser that comes back?
Yes. The laser hits the retroreflector and the laser comes back.
Okay, I'm unaware. I've only seen that retroreflectors bring back data on a computer.
No, it sends an actual beam of actual energized particles, which can hurt you if you get hit by them.
Mhm.
Physical particles.
Yeah, I'm not. I mean, I've personally never seen this. I don't know if maybe you have an example where you could pull up or show.
Well, if you just look at the blueprints of the retroreflectors, what they are is they're a series of mirrors that are built into a big dome, like an internal dome, opposite dome, I don't know, concave, convex, whatever. And so the way it works is you shoot a laser inside, and any direction you shoot the laser, it'll come directly back. And you can just build a model and show it does this because we have the blueprints of exactly what the retroreflectors are to know how they work. And so you can just build them and take a laser pin, and it'll do the same thing.
But you wouldn't suggest that like blueprints of something means it does exist and it is where they say it is.
Well, no, the blueprints are just to show how it works because you asked how retroreflectors work. So we can show how they work by here's the blueprint. So you can build this thing and say, if this is the thing that's on the moon, then anytime you point a laser at it, it will bounce it directly back in the direction you pointed the laser at it. And then you can say, well, okay, so if that's on the moon, we use a powerful laser on any of the big laser machines, it'll do the same thing. And that's exactly what we see. And it's been tested and done by hundreds of different labs around the world, hundreds of different colleges, hundreds of different individuals who rent those things.
Yeah, I listen, I hear what you're saying. I've just never seen any evidence of this actually being done. Now they say that they do that, right? That's fine.
Yeah.
Right. But I've heard arguments that you've made in the past on this specific debate that in fact you go to an observatory and you can rent it for the night and they give you the machine that shoots the laser but sends it back to your computer with data on it.
Sure,
Is that not the
you can
case?
just build your own if you want. That's fine.
So that I'm not actually receiving a laser directly back to me. I'm shooting a laser at a specific set of coordinates and then data is popping up on my computer saying, yep, that's the reflector.
No, it's a laser. I mean, things read lasers like computers. So it's a laser. And you could build your own computer to read the laser if you want, and then it won't just be a computer screen. It's an actual laser. If you have a sensitive enough eyes, you'll see the laser. I don't know if I doubt you do, but you can. If you have a little sheet, there's certain retro reactive sheets or something. I forget what they're called. If you put the laser in front of it, it'll leave little dots on the sheet because when laser hits it, it causes a reaction in the paper that causes little dots. You can use whatever medium you want to read the laser.
Sure. I mean, I would love to actually see this, right? I'm not familiar with it at all.
And you can do it. You can just go to the lab, be like, hey, I'm a flurf. Could you show me how this works? And they'll show you.
Why
Right,
do you
might-
guys say flurfs? I don't get it.
It's a funny sounding word. It's like
Okay.
potato.
It might be good to move on from this one. I think we've discussed lasers. You remind me of an old 2000s meme. I'm a fire in my laser, if anybody knows what that's from. So let's carry on and talk about the technology which you brought up there, big country.
Technology. I think the second thing was you need more fuel to go longer distance or something.
Yeah, the tyranny of the rocket equation.
Yeah, so it's simply false. You don't need more fuel to go longer distances. As long as you get outside of the pull of gravity, you can go as far as you want, and you'll never stop with zero fuel.
Okay, so it says here the tyranny part of the term emphasizes the significant challenges posed by this equation. To increase a rocket's payload capacity or velocity, engineers often need to design larger and more powerful rockets, which in turn require even more fuel. This creates a cycle of escalating cost, technical complexity, and diminishing returns. Overcoming the constraints imposed by the rocket equation is one of the central challenges into space exploration and rocket engineering. So,
Do you know what a payload is?
Uh-huh.
What is it?
It's the device that they're traveling with.
Yeah, just the amount of weight it can lift off the ground.
Mhm.
And so it obviously, if you're stuck to a big planet and you want to carry more weight, you need more fuel to get off the ground. But what it didn't say there was distance. It didn't
Okay.
mention distance once. So you can take any object of any weight and it can travel infinitely far as long as you get it moving, because objects in motion remain in motion. And so maybe you just misspoke and you added distance there accidentally. But yeah, it definitely takes more fuel to get things off the ground that are heavier. Agreed. But it doesn't take more fuel to travel longer. That is not the case.
Well, that's presupposed. Sorry, that went down the wrong tube. But that's presupposed, right? You're talking about gravity pulling you in and with other planets and stuff, right? This is what you're talking about.
No, like
Like if I'm traveling in a
space.
distance in space,
Uh-huh.
right?
Yeah.
And I happen to skirt by a planet, right? The force of said supposed gravity could change my trajectory.
Yeah.
Right, but that's all presupposed.
I'm not sure what you mean. So the first law of physics, objects in motion remain in motion.
Sure.
It's just
Mhm.
that if you're without like another force like gravity or something, you're just going to keep going. It's just not the case that you need more fuel to travel further. And I think it's a law called the Cassini rockets or Cassini satellites that they send off in both directions. They're just going and going, and they've gone farther than any other human built thing in the solar system, and they have no fuel. They have zero fuel. They just don't have anything to propel them. They're just going.
In the sky vacuum.
Yep.
Okay. Okay. That's fine. That's fine.
I mean, I don't know why it's funny. It's pretty obvious. Like air bottom dense, air top not dense. Keep going. Less dense, no air.
No container?
No container. You don't need a container.
Can you prove that
Yes.
with a test?
Yep. And carbon dioxide. So like you take a box, take some like colored gas, pour the
Mhm.
colored gas in the box. If it's heavier than say like helium or something, it'll just fall into the bottom, and then you'll just have a little gas with gas pressure, and then you'll have nothing above it with zero pressure, and it'll just sit there
Forever.
well, I mean, until you break it or something,
So the gas will never leave that open container.
Nope.
That's what you're saying.
because it's pulled down by gravity. So because
That's
there's heavy gases
100%
and
not
light
true.
gases, if you have a heavy gas, if you pour it and you color it and you pour it into a container in a complete vacuum, it'll just stay in the container because it's a heavy gas. It'll just float to the bottom and stick there, and there'll be zero of the gas that flows up because it's heavy.
You said, sorry, say that one more time. If you put it in a what?
Like a container without a top. So just like for like a glass fish bowl with no top. So you put a fish bowl with no top. It was colored. You can actually see it pooling at the bottom, and it won't go up. So there's a vacuum because there's no top, but you can see it. Like if you got rid of the container, it would just go to the bottom of the room, and you wouldn't be able to see it because it'd just be so big. But if you keep like a little container there, like a glass jar that's open, you can actually see it pool at the bottom.
So, but it's in a container, right? Is what you're telling me?
No, because there's no top, which means there's a direct connection to a vacuum.
So that gas would stay indefinitely in said open container is what you're telling me.
Yeah, because of gravity, it's just going to sit there at the bottom. It's never going to expand. It's never going to go up. It's just going to stay in the container the entire time, forever, until you get rid of the vacuum.
Yeah, I think that's not even kind of true.
It's been proven. We literally have done this in many
You've-
of the different things. Yes.
Okay, so you've pressurized gas.
What? So we've just taken gas, like heavy gases.
Like sulfahexafluoride or
Sure. And we just,
synthetic gas, but whatever.
yeah, it doesn't make a difference. Just any heavy gas you want, take it into a jar of any kind, go to a vacuum chamber, big one, suck out all the air, and then just like take a hose and just pour it in or whatever slowly, and it'll just fall to the bottom of, if you want a fishbowl or something, so that it stays and you can see it. Because if you just do it in the room, you're never going to see it. So you put a fishbowl there with no top, so there's a direct connection to the vacuum, and you just pour it in very slowly. It'll just fall to the bottom of the fishbowl and just stay there. It will not continue to expand. There's a maximum rate of expansion from the electrons to the protons and the neutrons, and that's how big it's going to get. It's going to get no bigger. And because of its weight, it's going to fall to the bottom. So there's going to be a bunch of these atoms that are stuck on the bottom. They're going to be really expanded, but they're going to be stuck on the bottom, and they're never going to move because they're heavy.
And this is in a vacuum. This is in a vacuum chamber, right?
Yep.
How do we achieve a vacuum chamber on Earth?
And just to inject, fellas, just to remind our audience how this interacts with the argument of whether the moon landing is a hoax or not, our gas and our vacuum. So carry on, gents. Just if you can remind our audience how this ties in.
I mean,
if
we
there's no
can
space,
change gear.
then
I
there's
did
no
say
moon.
I did say earlier that this was like not necessarily something I wanted to get into. I had mentioned that, but we wouldn't. I mean, it's up to you, TJ. We can move on. I feel like we're just going to keep going in circles.
If there's no space, then clearly the moon landing was fake. Like, duh.
Mhm.
It's kind of important.
Well,
It's kind of an
that would
important
tie
part.
it in. That would tie it in. Yeah.
But yeah, so how do we create a vacuum chamber on Earth?
Is it
we
in a
pump-
container?
Yes, we create a big container and we pump out all the air. And
Did you say that slower or?
yeah, so we have a container to keep the air out. We suck all of the air out, so then you have a vacuum, right?
Right.
And so then we have gas in this vacuum. This gas doesn't expand everywhere in the vacuum. It stays in a very small part of the bottom, right?
Right, but it fills the available volume equal
No.
to its
No.
buoyancy level.
No, it just falls.
So it
to the
doesn't.
bottom.
So if I pour gas in, it doesn't just stay in a pocket. It goes to the edges of the available volume that would equal its equilibrium.
No, it goes
No,
to
it
the
doesn't.
bottom.
It just stays in a pocket.
In the bottom, it just goes to the bottom. So it'll never go up. Never goes up. Never expands. It doesn't expand to the buoyancy level. It just goes to the bottom and sits there because of
It
gravity.
fills the available volume of its on the bottom of the container. It fills the available volume equal to
Sure.
its equilibrium.
Sure, if you grab
Because gas is omnidirectional.
No, that's the part that you're getting wrong. It's not omnidirectional. It only goes down.
Left and right,
Sure, that's not omnidirectional.
straight and forward.
That's still that's a 2D plane. You're missing the up and down, XYZ axis. So it won't
Yeah,
go up.
XYZ.
It'll never go up. It'll just sit at the bottom and
Ever.
stay there. It'll never go up.
Ever.
Even though there's less pressure above it. So there's less pressure above it, zero pressure above it. It'll never go up. It'll just sit at the bottom because of gravity. It'll just stay there, which means you have like at the very bottom, there's going to be the most pressure. And above that is going to be a little less pressure. And above that is going to be a little less pressure. And above that, a little less. And then there's going to be narrowed where there's no gas, just like the atmosphere.
Yeah, because see, I've never seen this test. I would love to see it. Right.
You can do
I
it
would love to
yourself.
see that. I maybe I will. Maybe I could film it and come back and talk about it. But if we can, real quick, we'll get back to what you had said there. So we get a container, we evac all of the air
So it's a
to
vacuum.
create a vacuum.
Yep.
What's the closest one on Earth that we have to space? 17 to the negative 4 to 4? 10 to the negative 17? 4 maybe? I'm not sure what it is.
No,
it's not.
It's significantly more than that. We have vacuum chambers that suck out everything and only let tiny, tiny particles through. The big ones, the big ones are not that powerful. But there's the smaller ones that are like this big that get you to pretty much as an absolute vacuum.
Okay. So I guess my question then is, in order to build a vacuum chamber, a vacuum chamber here on Earth, we have to put it in a room,
Clearly.
sealed.
Yep.
evac the air.
Yep.
Now, what's claimed to be above us, past the Kármán line, is space vacuum.
Yep.
No physical container.
Right. So I think you're really confused here because you think that if you're required to build a container to keep the air out, that means that proves that vacuums require a container or something. It's very, very bad logic. So to prove you wrong, I don't,
Sure.
it's totally fine to put a vacuum in a container to prove you wrong. All I need to do to prove you wrong is to show that gases will fall to the bottom in a vacuum. They won't equally float to all corners of the vacuum container. All they will do is fall to the bottom. Because if that happens, then it doesn't matter if we're in a container or not. Because if we're not a container, the gas will fall to the bottom. If we are in a container, the gas will fall to the bottom. So either way, the gas will fall to the bottom. And the vacuum of space is possible now. Vacuum of space has been proven because all the gas falls to the bottom. That means there's this little bit of gas here, gas, no gas, and there's no container between those two things. There's no container creating the vacuum. There's just gas that's falling to the bottom.
Although, sorry, go ahead. I want to jump in.
So it doesn't make a difference if we're in a bigger container or not. Space is still real because space, the lack of any atmospheric pressure, is going to be there simply by the changes in the density of the gas. And it doesn't make a difference if we're in a vacuum or not. And so that's the topic we're talking about. Is space real? That would prove space was real. Yes.
But it doesn't though. Not the way that it's described. I'm not saying that things that are up in the sky are a projection or not really there. I'm not saying that at all. What I'm saying is that it's a physical impossibility for a vacuum to exist next to a pressurized system without all of the air escaping into said volume. We would die instantaneously.
Okay, so that's the part I was addressing here. So let's say we have a container with a vacuum in it, and we have another container, just a little glass bowl of a heavy gas, and we put the glass bowl in the middle of the vacuum. Now, if you were right, the gas in the glass bowl would escape. It would leave the glass bowl. It would go out. It would fly everywhere, go all corners of the vacuum chamber. And if it doesn't, if it just sits in the bowl because of gravity, that proves your statement wrong because the gas isn't escaping. There is a pressurized gas system, the bowl, that has an open top that is directly connected to a vacuum directly above it. And the gas isn't escaping into the vacuum. It's just sitting in the bowl. Now, if that happens, that proves your previous statement completely wrong, doesn't it?
No. Because the open container is still in the vacuum.
Yes. So there's an open container that is
Are
directly
you suggesting
connected
that
to a
Earth
vacuum.
is a vacuum?
No, Earth is
'Cause
like
that would be your example.
no. So there's a bowl with some gas in it, like Earth has gas around it, and so there's some pressurized gas that's around Earth, and there's some pressurized gas in the bowl. So pressurized by the weight of the gas, and it's directly connected to a vacuum. There is a vacuum directly above it, and the gas is not escaping into the vacuum. It's just sitting there in the bowl because of gravity. And so if we have an object like the world that pulls gas towards it, even though it's directly connected to a vacuum, the gas isn't going to escape because the gas is like it's trapped in the bowl because of gravity. It's being pulled towards the thing with the gravity, in which case it can be directly connected to a vacuum and not escape. Just like there's a lot of gas in the bowl, which creates a pressurized gas system that isn't escaping into the vacuum, even though there's a vacuum directly above it.
Is that your final point? I don't want to.
Sure.
Yeah. I'm still not seeing how this proves anything that what is claimed in your model, and furthermore, we're demonstrating here that your independent variable in that test is gravity. So how are you manipulating gravity to ensure that it's actually the gravity is pulling gas to the bottom?
The independent variable is the gas.
No, that's not.
This is the gas. So
No, it's not.
what we're measuring there is
You said gas is staying down because of gravity.
right. We're not testing gravity. We're testing the effects of what the gas is doing. So we don't really care what's causing it to go down. It doesn't make a difference. It's irrelevant. We don't care.
That's the whole idea of science.
No.
It's
So
the cause
again,
and
you don't
effect
need dependent
correlation.
independent variables to do all kinds of experiments. That's just false. That's just a ninth grade level understanding of science. That's a very basic definition, not required for most scientific tests. But different topic. go back to this topic. We don't care about gravity. We don't care. Doesn't matter. We just pretend. Let's pretend there's no gravity. We don't care. The only thing we're trying to prove here is, can you have pressurized gas next to a vacuum, and can the pressurized gas stay pressurized and not go into the vacuum? That's all we want. Is that possible? So if we have a
No.
bowl and there's heavy gas in it, it's pressurized gas. The weight of the gas is pushing the gas down. We don't care if it's done by gravity, doesn't make a difference. So we have a bowl with pressurized gas, we put it into a vacuum, which means right above the pressurized gas, it's exposed to a vacuum, direct exposure to a vacuum, and it's not going anywhere, just staying in the bowl. There's a pressurized gas right next to a vacuum, not expanding. So that disproves your point that if a pressurized gas cannot exist next to a vacuum, because it literally is doing that and not moving.
I'd love to see this. I've never seen this, and as a matter of fact, I think that this would violate a couple of natural laws.
It does not.
Okay.
I mean, this has literally been done multiple times.
Do you have an
Pressurized gas-
example you could? Do you have an example you could pull up?
No, but if you want to talk to the people who actually keep these on file, like what's his name? Fight the Flat Earth, Creation Cats. They have these examples they can pull up for you. They have them saved. I don't have them saved. My topic is, does God exist? But they have all the data if you want it. This is a very common experiment. It's not. It's like it's pretty basic. And
it's funny that it's so common, because when we ask astrophysicists this question, they say, "Yeah, we don't know how that works exactly."
I've never heard, like, I've talked to physicists, they're like, yeah, we know exactly how that works. It's the gravity, strong electromagnetic force, and the weak force. There you go. Problem solved. That's how it works. I'm not sure, like, which part do you want to explain how it works? I can explain every part of that.
Well, I mean, listen, we could sit here and continually talk about it. I feel like we're going in circles. I don't know if you want to change topics. I mean, just keep it moving.
Well, I mean, sure. I mean, I'm not going in a circle. It's like we're talking to a brick wall, but I've gone in a straight line the entire time.
I think it might be a good idea to explore another idea. So if you want to kick us off, Big Country, and give us another example that you might have brought up in your intro, or even something
Sure.
outside of it, because you said you had other things as well.
Yeah, sure. So, what would be your explanation then, TJump, for certain astronauts saying, yeah, absolutely, you can see stars when you're up there, and then others astronauts saying that you cannot see stars up there?
Eyewitness testimony is garbage.
So one of them's lying.
No, I think it's probably most likely it's contextualized to the statement, like, did you see stars? And many of the astronauts could have said no because of the time when they worked or whatever. Could have been during the day when the sun was exposed, so they wouldn't have been able to see stars. And if you ask other ones, did you see stars? And they worked during the night or whenever the sun wasn't out, they could have seen stars. So that would have been one explanation, but I really don't care about their testimony. Testimony isn't evidence.
Well, no. Testimony is definitely not evidence, but the inconsistency of said testimonies of the people who have claimed to have been there is pretty damning evidence when they don't line up.
No, not at all. Actually, if we know anything
How's it-
about
how's it not?
testimony, there's an experiment done where we had 20 people.
Are these one of
and,
those experiments that somebody else has?
it's an experiment that's common. Again, lots of people do it. I go to colleges, we
Gotcha.
do this. So yeah, so I could
Okay.
do it right now. It's that we've done it a million times. Where there were 20 people put up to watch something go on. They weren't told what. Car crash happened right in front of them. They were all separated into different rooms and asked what they saw, and all of their testimonies differed because that's just how the brain works. This is not evidence of anything. Eyewitness testimonies diverge a lot. Very well known in law. This is not surprising at all.
So now, with the images that come back of said moon landing, right? Lack of stars absent in the background from videos and photographs. What would be the explanation there?
Probably because there wasn't enough light to expose the film to cause the stars to show up. Like literally, if you just take your phone and take a picture of the stars and you don't set it to a high exposure, you won't see most stars. Then if you set it to a high exposure, you'll see the stars. So if the camera was set to a low exposure, it wouldn't see the stars. Very basic. Absolutely nothing challenging about that.
Okay. Do you have Ryan? Can I get screen share for a second?
Yeah, sure thing. Just let me know when you're ready. I will remind everybody once
yes.
again, if you haven't, hit the like button. We are going to once again, I'll say it again while you get your screen share up. We're going to be doing our Q&A here. We still got a little over an hour, I'd say, of conversation, and we'll head in there. So whenever you're ready there, Big Country.
Yeah, I'm ready.
All right.
Oh, did you enable it? Okay,
Yeah, it's ready when you are.
I
Just
gotcha.
hit screen share on Zoom.
Cool. Oh, there we go. Okay,
There we are.
is that working?
We're up and running.
Okay, cool. I didn't know if you could see the whole thing or not. So TJump, I'm sure you've seen this. This is India, just a few months ago, landing on the South Pole.
Nope.
Okay. So based on your belief in the moon landing, right? Let's full screen it. Let's go back a little bit. This is a live video that they played as the lander was landing. So I guess my question here, TJump, is do you believe that's a real video?
No, doesn't look like it.
Okay. And the stars in the background.
Well, it looks like it's computer generated. Like there's no shadows on the machine at all. It looks like computer generated stuff.
I agree. I listen, I 100% agree with you. We're finding common ground here. So why would India show this video live and say that it's them landing on the moon and NASA confirmed it? Why would they do that?
They do artificial representations of the thing that they're doing because they can't show
It's a
the actual thing they're
live
doing.
video, my guy.
Right. So I do live videos every day, and they're just reruns of other things that I've done because I like it's just to represent the stuff that you're doing. Like it doesn't mean that it's literally the actual video. It's not how it works.
Gotcha. So a fake live video. Got it. This one here was from when we launched back from the moon. Ignition. Was that like sparklers that came off of that?
I
Or
have no
pixie
idea.
dust?
Probably pieces of metal from the explosion that launched it forward.
Wow. No stars, so that's interesting because India showed stars in their live fake video. Do you know the delay that they said that the camera was on? You can stop screen share there, Ryan.
No, I don't care.
I think they said it was 3 seconds. Did that look like a 3 second delay? Because that was perfectly centered to frame when it took off.
What the delay wouldn't have made a difference. So the camera
I'm
that's
sorry.
right next to the thing that you showed wouldn't have had a delay. It would have just literally been showing the actual video real time. The 3 second delay would have been like how long it takes to update the video to the computer or whatever. But the video was being recorded live. So it wouldn't have the video itself occurring wouldn't have taken 3 seconds. It would have taken 3 seconds for it to transfer to the computer and then be sent back to Earth.
Okay, so how is the camera filming that uh lander, whatever you want to call it? How's it filming that?
I'm not sure what
I mean,
you're
there's no
asking.
one there. There's no one there, right? They didn't
Right.
leave somebody on the moon.
Right. So they set up a camera
Uh-huh.
and they set it to watch the thing and then to track an object most likely. Or they just set it up to go up at a certain speed after like if they set the ignition point to be, I don't know, 5 minutes, they could set the camera to wait 5 minutes, then pan up. Like there's a bunch of ways you could do that. None of that is spectacular. Like an eighth grader could do that in their backyard.
And they did that in 69?
Yes, like literally an eighth grader could do that right now with Legos. That is not hard at all. Like a Rube Goldberg, you could just set like a string and a rock, and then if you set the string to be long enough and set the rock to fall down a hill, it will eventually cause the camera to pan up. That is very, very not hard to do for an eighth grader 50 years ago. No.
Okay. So the claim here is that they set up some type of time delayed remote control apparatus on the camera to perfectly film when they launched off to track it. What was the model that they used? Do you know?
No, you could use like a billion models. Anything would work. Stick holding camera up could work, and the vibrations cause stick to fall and then camera pan up. Very easy. Like none of that, absolutely none of that is even surprising.
That's an ad hoc rescue fallacy.
No, that's just a basic example of how to do the thing you're saying is really hard, which is actually just a really basic thing that could be done in a billion ways.
Because you don't have any proof of them actually doing specifically that, right? That's just your
Right.
theory.
Right, because I don't need proof. Like if I can give one example of a very easy way to do the thing, they could make up a better way to do it. Sure, a more accurate way. Absolutely. Do I care? No. There's a million ways to do it, and they all would
Mhm.
work. It would all work.
It's really interesting. Hopefully, everybody in the chat knows, because this is what I said in my intro. I said everything that we're going to hear tonight that are supposed claims of validating that we land on the moon is none of them are going to be verifiable whatsoever.
What? Well, that is verifiable. Can you make a camera pan up on an
Yeah, of
artificial
course I can.
timer with a
Sure.
stick?
In 2024, yeah, absolutely, yeah, I can.
People could do this in 2000
In
BC. This is not hard. If they had a camera, they could do it. But so having a camera on a timed device that causes it to pan up is very easy. You do it with a stick. It's like how they caught rabbits. They tied a stick to they bent it over, and when there's any vibration, the stick would fling up and they'd catch the rabbit. The exact same thing. You could do that with the camera too. Any vibration causes the stick to go, and it would fall, and it would go up. And this is very easy. The technology to cause a camera to pan up, or to cause anything to pan up, existed 4,000 years ago.
So you are okay. And I don't mean to sound rude. It really just sounds like you're making random shit up
How is
and
that
throwing it
making
to see if
anything
it
up?
sticks.
What like if I say a basic fact that is super obvious and everybody knows about, and you're like, you're just making stuff up, it doesn't seem coherent, because you're not, doesn't seem like you're listening. Because if I say something
No.
that's super basic that everybody understands, that everybody knew about thousands of years ago, and you're saying you're making stuff up, that doesn't make
Thousands
any
of years
sense.
ago?
Yes, like how to cause things to fall on a delayed timer is very easy, extremely easy. 3,000 years ago, we could do this.
I think we've explored this one. If we want to move into some new territory, I think we've come to a stop here. So if you want to continue on there, big country, if you got another example or something from your intro, we'll keep rolling down.
Yeah, sure. I guess we talk about the fact that we have no idea what the moon is, right? So we don't even know
rock.
if it's terra firma.
What? Terra firma. Terra firma is like another word for Earth. What does that have to do with
Yeah.
being a rock? It's a rock
How do you know it's a rock?
because we have parts of it. I mean, there's multiple ways. We can use light informatics, which will show what its material consistency is by bouncing light off of it, so we can know what it's everything that's made of from doing that. We also brought out parts, so we know it's a rock.
So the parts we brought back, the one that we know of that's been tested is petrified wood.
No.
So is there?
There's
It's
lots
not?
that we know of. There's lots that we know of. They've been tested. We know they don't have any hydrocarbons in them or whatever. I think that's the word. So to show that they are literally different from any earth rock because they don't have the right composites of organic based compounds that would be there if it was an earth rock. So we know exactly what it is.
And do you have an example of one that you could pull up, show? Hey, this one was actually tested to be a moon rock.
Nope. Again, you could ask the people who would keep the data on that, which would be like Creation Cats, Fight the Flat Earth.
Gotcha. So no is the answer.
No, the answer is yes. I don't need to provide it because it's already there.
We're in a debate talking about this, and you're like, I don't need to prove anything that I said.
No,
Just believe it.
It's like you say, do I need to prove the sky is blue? Nope. You can just go look yourself. It's fine. It exists right there. First search
So
on
for
Google.
somebody who's colorblind, it wouldn't be.
Right. So I mean, but if you're basic facts blind, that would be the more fundamental problem that you might want to figure out.
Okay, so, you said earlier, what did you say first about what we got to moon rocks? You said we do something to the moon. I didn't
What?
hear what you said. That we know what it is.
Light spectroscopy. Light
Spectroscopy.
yes,
What
spectroscopy.
Spectroscopy. What is spectroscopy?
It means you bounce light off things, and the way it bounces back tells you what materials it's on because the different atoms reflect light differently.
Are you sure that's what spectroscopy is?
Pretty sure.
Okay. Do you know what the three spectras are?
Specters? What?
Spectras.
Spectras?
Spectras for spectroscopy.
Spectras for spectroscopy? I don't. There's not three.
There is three.
There's not three.
Continuous absorption and emission.
That's not what is a specter?
A spectra is how we view things, right? So, continuous is a solid or liquid. An absorption spectra is gases with a light behind it, and it's produced by energization. And emission spectra is gases with light behind them and produce cool thin lines. This is how we view it on the Roy G. Biv.
Okay. And
So
what does that have to do with anything I said?
Okay, so you brought up spectroscopy.
Right.
Are you aware that there's two forms?
There's more than two forms.
There's only two.
No, there's not. That's wrong.
There's terrestrial. There is celestial and terrestrial. There's only two.
No. In fact, there's
Yep.
lots of different forms that have to do with the wavelengths of light. It has nothing to do with where you're looking. So that's incorrect. You just don't know basic facts here. So like there's infrared spectroscopy, there's X-ray spectroscopy, there is regular bands of light spectroscopy. So there's just not
Yes.
two. You just made that's just not
There's
the case.
two. It's
No.
celestial spectroscopy and it's called atomic absorption, which covers
No.
UV.
So I just proved you wrong on that one.
No,
it's
no.
wrong. Next.
No,
Yes, you were wrong. Next.
no, I'm not.
No, you were wrong.
Celestial
It's okay. You can be
spectroscopy
wrong. It's fine. It's
is
fine. You're
atomic
wrong most of the time. You're a
absorption
flurf.
spectrum.
But are you going to address
I'm
what I said?
explaining to you I'm explaining to you
You're a
spectroscopy.
flurf. You're wrong. It's okay. You're wrong. We know you're wrong. But are you going
This
to
is
try to address
wild.
the argument? That's all.
Yes.
Let's give Big Country a chance to explain what he was trying to convey there, and if there's any confusion, and then we'll move into a new subject. If that's
Sure.
good, fellas.
Okay.
Well, no, he's has to address the argument. So yes, we do light spectroscopy. We can see what the moon is made of, and he's going to say no for some reason, but he hasn't.
Yeah, correct. Because I'll break down how spectroscopy works here.
Well, you don't know, so that's not going to help. You just skip to the part of why you think it doesn't work. I tell you why you're wrong.
right. Well, let's give him a chance to explain that, and then of course we'll give you the floor there, TJump. So go ahead there, Big Country.
Okay. So terrestrial spectroscopy is an atomic emission spectrum. It's inductively coupled plasma electrothermal graphite furnace. So what we do is we take something, we want to know what it's made of. We take it, okay, and we put it in this machine. This machine,
Nope. So I don't know how this has anything to do with what I said, because we don't do that to the moon. Next.
dude,
Let's
this is
carry on there.
terrestrial spectroscopy.
Right. So you're trying to explain to sound smart. You don't sound smart. Can you get to the part where you object to my argument of this doesn't work for the moon because magic,
Terrestrial spectroscopy.
which has
Atomic-
nothing to do with the moon?
Holy fuck.
All right. Let's let him explain their TJump so we can move on.
No,
from
I'd like
here.
to explain how dinosaurs have wings. Is that relevant to the debate? No, it's not. Why? Because it has nothing to do with the moon. So if he could explain how it has something to do with the moon, yes. If he wants to tangent off of random topics that have nothing to do with the moon, no, because I want to stay on topic of the debate.
Well, then we'll let him add on how it ties into the topic after he's done explaining. So
No,
we'll
then
let you
I
explain
want
that,
to
and
monologue
then-
about dinosaurs.
Oh,
I want to monologue about my church or my religious doctrines. No, well, let's stay on the topic.
I'm trying to.
Okay, how does this relate to the moon?
Well, if you wouldn't incessantly interrupt me, I would tell you.
All right, without the meta, let's try to avoid the meta. Let's try to get into it, Big Country.
Okay, terrestrial spectroscopy, atomic emission spectrum, individually coupled plasma electrothermal graphite furnace. This is what we do. We take the item that
Okay,
we're
I'm still-
trying to.
We don't do that to the moon. Literally,
All right,
we don't do that.
we
to the
gotta
moon.
let him talk. TJump. I've asked you several times
Dude,
now.
the
We gotta
chat's
let him
seeing
explain.
it. I don't.